This might be the most advanced and spotless factory on Earth. It's not just keeping up with the future, it's shaping it. A place where human ambition and cutting-edge technology work side by side to push the limits of what's possible. Constant innovation isn't just encouraged here, it's a necessity. If you don't keep improving, you get left behind.
If you cannot innovate, you will not survive in this industry.
At the heart of this operation is a surprisingly simple element: silicon. Found in sand and one of the most abundant materials on the planet, silicon is the starting point. But what they do with it is anything but simple. Layer by layer, they etch billions of microscopic circuits onto it, creating the brains of modern electronics. And as the chips get smaller and more complex, their job is to fit even more power into even less space. It's a race with no finish line, where every day brings a new challenge. In today's world, where nearly everything runs on computing power, this factory is building the foundation of tomorrow. Come Monday morning, the pressure is at its peak. It's the busiest time for energy and water usage. And in a place where precision is everything, even the tiniest hiccup can cause chaos. A single malfunction could shut down the floor and cost millions in lost productivity. That's why the factory's control room is treated like a mission control center. Some even call it the spaceship. Packed with monitors, systems, and real-time data, this is where every major utility is managed: electricity, water, air, and chemicals. Overseeing it all is Rex Lai.
到 Starship 就是新建里面的那个舰长所在的位置，它相当于就是我们厂务的大脑，那控制了整个厂区的电力的系统、水的系统、空调或者是这些化学品的管控。
He's the one who keeps the entire operation balanced, making sure that nothing slips and that the lifeblood of the plant continues flowing. Semiconductor production is an incredibly complex process, involving over 1,000 intricate steps. If just one of those steps fails, everything can come to a screeching halt. Restarting isn't easy. It takes time, effort, and money. That's why this control center is so critical. It keeps the rhythm of the entire facility steady and uninterrupted. And at the core of all this is the semiconductor itself. Silicon has this unique ability. It can either allow electricity to flow or stop it, depending on how it's treated. This simple trick is the secret behind how microchips work, turning tiny switches on and off millions of times per second to power everything from phones to satellites. So, while this might look like just another factory from the outside inside,
这个元件我们一般称为电晶体。电晶体它其实就是一个开关的功能。这样的一个元件的特性呢，它就可以应用在数位，所有的讯号只有用0跟1来表示。
it's a technological marvel, a place where science, engineering, and vision come together to build the digital world we all rely on. And every single day, the future starts all over again, right here. At the heart of every digital device is a tiny but powerful component, the transistor. Think of transistors as microscopic switches that turn on and off to control the flow of electrical signals. In digital systems, everything is built around binary code, zeros and ones, and transistors are what bring those numbers to life. It might sound unbelievable, but a microchip is essentially a dense network of billions, sometimes hundreds of billions, of these switches working in perfect coordination. But of course, it's not as simple as flipping a few switches. These components are packed into structures called integrated circuits, where astonishing numbers of transistors are crammed onto a single chip, smaller than a fingernail. The chips inside modern smartphones, like those from Apple, contain more transistors than there are people on Earth, each one playing a role in enabling everything your device does. These transistors are the true building blocks of all modern computing, forming the backbone of processors, memory, and everything in between. The capabilities of a chip are directly tied to how many transistors it holds. The more transistors you can fit onto a chip, the more powerful it becomes. It can perform more complex calculations, run more applications, and do it all faster and more efficiently. From enabling instant communication to supporting life-saving medical devices and powering next-gen military systems, transistors are the unsung heroes driving today's technology. When it comes to manufacturing these highly sophisticated chips, one place leads the pack: Taiwan. Despite its relatively small size, Taiwan plays a massive role in the global semiconductor industry. Thanks to decades of expertise, a strategic location, and an ecosystem designed around high-tech production, the island dominates the field.
晶圆代工大概在全球大概占到将近70%，先进制程部分占到高达90%以上，后段的封装还有测试的部分也是全球第一位。
Taiwan produces around 70% of the world's foundry chips, and more than 90% of the most advanced chips used in cutting-edge devices. But it doesn't stop at chip fabrication. Taiwan is also a world leader in the back-end stages of production, assembly and testing. Across 3 major science parks, stretching from the northern to the central and southern regions of the island, there's a tight-knit network of factories and research centers working together.
Taiwanese tech giant TSMC warns an invasion of the island would render its factory inoperable, devastating global supply. Tensions are rising ahead of a potential visit to Taiwan by US House Speaker Nancy Pelosi, and the growing chip shortage continues. Last week, Taiwan said its key position in making semiconductors won't be shaken in response to the US passing a law to subsidize its domestic semiconductor industry in an effort, it says, to compete globally. Europe wants to ramp up production. Germany's been trying to clinch a deal for a plant from TSMC, the biggest player. The company's factories in Taiwan are running at full capacity to alleviate the shortages.
It's a fully integrated system, covering every stage of semiconductor production. At the heart of this ecosystem is TSMC, Taiwan Semiconductor Manufacturing Company, the undisputed global leader in advanced logic chips. These are the processors that power everything from iPhones to data centers. Just as TSMC dominates logic chip production, another major player, Micron, leads in memory chips, specifically DRAM, which is essential for devices to multitask and operate efficiently. Micron may be a US-based company, but Taiwan is its manufacturing powerhouse. With a sprawling factory complex and nearly 3 decades of investment on the island, Micron has firmly embedded itself in Taiwan's semiconductor landscape. Today, about a quarter of Micron's global workforce operates in Taiwan, and the country produces 65% of the company's DRAM, giving Micron nearly 10% of the global market in that segment. That's a massive footprint. One of the crown jewels of this industrial might is Micron's Mega Fab.
2 manufacturing plants, one in Taoyuan, Guishan, the other one right here in Taichung, Houli. I'm not going to tell you how much it is, but it's a mega factory. Semiconductor manufacturing, today it's involving more than 1,000 steps. And we are not talking about just getting one step correct. We are talking about getting all 1,000 over steps correctly lined up to be able to have a functional chip.
A colossal facility that shows just how serious Taiwan is about staying ahead in the chip race, covering about 1 million square meters, roughly the size of 140 football fields. This isn't just a factory. It's an entire world dedicated to chips. Everything happens under one roof: research and development, manufacturing, assembly, testing, and even sales and logistics. Micron operates 2 major factories in Taiwan, one in Taoyuan's Guishan district, and the other in Houli, Taichung. Together, they form the core of the company's Asian operations. The scale and investment are staggering, but this success didn't happen overnight. It took years of planning, engineering excellence, and relentless attention to detail. Much of that precision can be credited to veterans like Zhong Lian Bin, who has spent over 30 years in semiconductor engineering. He's known for his perfectionist mindset, a vital trait in a field where even the tiniest mistake can ruin an entire chip batch. Zhong personally oversees every part of the process, making sure nothing is left to chance. In a business where accuracy is measured in nanometers, there's no room for compromise. Taiwan's dominance in semiconductor manufacturing isn't just about machines and materials. It's about people, discipline, and a culture of excellence. And in places like Micron's Mega Fab, the future of technology is being built, one atom-thin layer at a time. Creating a modern semiconductor chip is one of the most complex engineering feats on Earth. It's not just about precision, it's about executing over 1,000 individual steps in the exact right order. If even one step goes wrong, the entire chip can fail. It all begins long before anything physical is made, at the design stage. Designing a chip is like planning a massive city in miniature. Engineers decide where each of the billions of transistors will go, how the components will talk to each other, and how the layout can be optimized for speed, power, and efficiency. It's similar to building a skyscraper. Architects handle the structure, engineers plan the systems, and everything has to come together in harmony. Once the blueprint is finalized, the real work begins, inside the fab. The fab, short for fabrication facility, is where chips come to life. But getting inside isn't simple. The number one enemy here is dust. A single dust particle can destroy an entire batch of chips. That's why anyone entering the clean room must first wear a full-body suit known as a bunny suit. Despite its name, there's nothing cute about it. It's essential. Its job is to keep out hair, skin flakes, lint, and any other microscopic contaminants we constantly shed. Even the changing rooms are engineered for cleanliness. Every surface, from benches to shoe racks, is made of stainless steel. Once suited up, workers still must pass through an air shower, a chamber that blasts filtered air to remove any remaining particles. It lasts just seconds, but it's crucial. Inside, the clean room is 100 times cleaner than a hospital operating theater. But cleanliness is only the beginning.
It's like half a minute out of 1 million years. That's the amount of the control that we have to in order for us to be able to have successful wafer fabrications.
The actual chip-making process involves some of the most advanced machines ever built. It starts with a pure, flawless 12-inch silicon wafer. This wafer is coated with a light-sensitive material using a process similar to spin-coating paint. Then comes one of the most important steps in chip making, photolithography. Photolithography is like ultra-precise photo development. A design template, known as a mask, is placed over the wafer. Ultraviolet light then shines through the mask, imprinting the chip's blueprint onto the wafer's surface.
60 years ago, a transistor we are able to see using humans' naked eyes. Today, the size is in fact like almost 10,000 times smaller than a human hair. That's huge amount of innovations, especially coming from photolithographies, in order for us to print or define such small patterns onto the wafers.
Where the light hits, the photoresist hardens. The rest is chemically etched away. This process is repeated again and again, layer by layer, until the entire circuit is built. Each pathway etched onto the chip is measured in nanometers, just a few atoms wide. At this scale, even the slightest contamination can cause massive defects. That's why most of the chip handling is automated. The less human contact, the better. Across the factory, tiny robotic vehicles glide silently along overhead rails, moving wafers from one machine to another. These automated carts are fitted with sensors to avoid collisions and adjust speed based on traffic. There are thousands of them, traveling over 400,000 kilometers a day, about 10 laps around the Earth. It's a system built for both speed and cleanliness. In the early days, human workers had to load and move materials by hand. Now, thanks to automation and remote operation systems, one technician can manage dozens of machines from a single control station. It's a dramatic shift in how factories operate. And the scale is massive. On any given day, a modern semiconductor plant may be running more than 5,000 machines. Yet, due to smart automation, a single shift only needs around 70 to 90 highly trained staff to keep things running. Gone are the days of manual labor. Today, workers focus on monitoring systems, analyzing data, and making intelligent decisions. One of the people leading this transition is Wolfchain. He manages the operations team responsible for the clean room's performance. His team oversees nearly 100 separate workflows happening in real time. To do this, they rely on more than 50,000 sensors embedded throughout the plant, feeding into over 250 million data points. All of this generates a massive stream of information, up to 30 petabytes every day. That's more data than many major internet platforms handle. This data is filtered, merged, and visualized on large screens that highlight critical metrics, production goals, and potential issues. With this system, operators can instantly see what's going well, where attention is needed, and what to prioritize. It's not just manufacturing, it's orchestration at a scale that few industries can match. Every chip that emerges from this facility represents not just silicon and circuits, but a triumph of design, engineering, automation, and data mastery. Once the chips have passed through rigorous testing, around 80% of the entire manufacturing journey is complete. But the final and perhaps most delicate stage still remains, transforming these tiny silicon marvels into usable, durable components ready for the real world. Each silicon wafer holds hundreds or even thousands of individual chips, all with their own microscopic circuits etched onto them. Now, they need to be separated with incredible precision. Surprisingly, one of the most traditional techniques still leads the way: cutting with diamond-tipped blades. These blades slice through the wafer, dividing it into individual chips with surgical accuracy. Once separated, each chip is carefully placed onto a circuit board, but placing them is just the start. These chips must also be connected to other components so that they can send and receive signals. That's where gold wire bonding comes in. Using ultra-precise machines, delicate strands of gold wire are attached, thinner than a human hair, bridging the chip to the circuit. It's meticulous work, done at a scale invisible to the naked eye. But the chips themselves are extremely fragile. Even the tiniest bit of moisture, corrosion, or physical stress can ruin them. So, the next step is protection. A specialized coating is applied to shield the chips from mechanical or environmental damage. Then they are encased in their signature black packaging, the tough shell that makes them robust enough to be installed into devices. Once sealed, every chip is tested again. Not one can afford to have defects. Those that fail to meet the highest standards are instantly rejected. The rest are laser marked for easy identification, barcodes for the digital age. Now, they're ready to ship. Ready to power the world's devices, from smartphones to satellites. This entire process has reshaped our world, and as the demand for faster, smaller, more powerful chips grows, the industry keeps evolving. But all this progress comes at a price. Chip manufacturing today is far more complex than it was in the past. What used to be dozens of steps are now hundreds. That complexity demands more energy, more water, and more raw materials. Back in the control hub, often called the spacecraft by the team, Rex Lai and his crew are focused on reducing the environmental toll of such a massive operation. That's why they've developed the world's first chemical concentration recycling system. Inside this plant, chemicals like isopropyl alcohol, IPA, which were once disposed of at low concentrations, are now recovered and purified up to 80%. These reclaimed chemicals can be reused or resold, giving them a second life and reducing waste. Water, too, is a major concern. Semiconductor fabs consume huge amounts of it, but fresh water is becoming scarcer across the globe. Here, nearly 80% of the water used in the manufacturing process is captured, treated, and recycled. That's a significant cut in consumption, one that helps conserve this precious resource. But environmental responsibility doesn't stop with recycling. The factory has taken a vertical approach to sustainability. In its newest facilities, green walls covered in living plants have been added, creating more than 18,000 square meters of natural green space. These vertical gardens don't just look good. They reduce the need for air conditioning, cut energy use, and help create a healthier work environment. Much of the plant is powered by renewable energy, enough to match the electricity needs of a small town. And unlike many industrial sites, this facility focuses solely on making chips. No extra products, no unnecessary waste. The goal is to leave the lightest possible footprint. In Taiwan, where natural resources are limited and land is precious, these innovations matter. Against the odds, this small island has risen to become a giant in global chip production. It's a story of ambition, resilience, and brilliance, of how a community of determined minds built something that powers the digital age. Semiconductor manufacturing is a stunning blend of science and art. where every nanometer matters and precision is everything. Inside these high-tech mega factories, teams work around the clock to push humanity forward, layer by microscopic layer, chip by chip. So, the next time you send a message, stream a song, or capture a memory with your camera, remember that behind that instant moment is a miracle of engineering and human ingenuity. A journey that started in a clean room and ended in your pocket. The future isn't just coming, it's already here. And it's being built, one chip at a time,